Thank you very much, Paul. Good morning, everyone. My name's Shaun Dowman, Agricultural Advisor for Affinity Water. I just want to start by thanking the Groundswell team for inviting us to be part of this event, inviting us to sponsor the event. This is our second year sponsoring Groundswell now, and you know, we're really impressed. We're really impressed with this event. It's so amazing that they've done it all themselves, and it's really great to see it grow from last year. And yeah, we're really looking forward to learning more about soil health over the next couple of days. So yeah, please do come and speak to us. I'm just going to give you a short presentation. I'm going to step to one side because I'd like to. Can you hear me with the? Yeah, excellent. I'm going to step to one side because I want to relate to a few slides. But I need to point to the guy over there to click each slide. Yeah, if we could go back. Sorry, back a couple. Yeah. So a bit about me. I live just down the road in Royston with my family, my wife and two children. My youngest daughter Audrey is only 3 months old, so I'm very much suffering from sleep deprivation at the moment, so bear with me if I suddenly become incoherent. Sorry. Yeah. Just a brief overview of my background, really, my experience. I'm an environmental scientist, and I have a background in environmental monitoring. I've been lucky enough to travel around the UK monitoring our freshwaters, performing biological and chemical surveys of our freshwaters. And I've seen some really great lakes and rivers in wonderful condition, and also some very polluted rivers as well. And in that time, that's given me, I think, a good understanding of this habitat and what sort of things impact our freshwater environment. More recently, I've been working for Affinity Water, and we're sort of moving into this world of catchment management, where we're trying to understand how land use in catchments influences water quality, with particular reference to public water supply, the things that impact drinking water. And I think, you know, what we're going to hear over the next few days is people really talking about how wonderful soil biology is, and that you know, how it's packed with life, with billions of organisms in each handful of soil, and the diversity there, and how important that all is in the functioning of the soil. But I think it's a nice parallel, actually, just to also highlight how diverse and packed with life the freshwater ecosystem is as well. And it's this hidden world as well, like the soil, and there's lots of stuff going on there. There's the diatoms and the algae and the invertebrates, all doing really valuable things, and the freshwater environment is a really good indicator of the health of a landscape, and it will respond to different pressures and tell you really if something's wrong. And we do use biological organisms to help us understand this. So I just think that's a good point to make before I move on. So take a step back. I'll introduce you to the company I work for now, Affinity Water. We are a water supply company operating in the southeast of England. The blue area is where we supply water. We supply about 3.5 million people, and we get about 60% of our water from chalk aquifers. And certainly in this part of the world, we are very reliant on this particular source. We also get about 40% of our water from the River Thames as well. And we do operate within a severe water stressed area. We've got a high population, we've got an increasing population, and we have relatively low rainfall per head of the population. And obviously what's been happening over the last few weeks with the dry weather sort of highlights that, really. Okay. And so why are we here? Why are we supporting a no-till sort of soil health event? I mean, firstly, we know the Cherry family well, and you know, it's great just to support a fantastic event in our patch. But also, it's more fundamental than that. Obviously, you know, we know that the health of the soil will have an impact on the freshwater environment, and this is where we get our raw product from. So it's within our interest to support good soil management and soil health. So, okay, thank you. So what specifically am I going to cover? I'm just going to briefly talk about what is catchment management, the field that I work in, and just highlight some of the water quality challenges that we face, and sort of with particular reference to agriculture really. And then I'll briefly talk about some of the water supply challenges and offer up some potential solutions at the end. So what is catchment management? I'm sure many of you are familiar with this field and this term, and it's something that is growing in recent years. Only a few weeks ago we had the Catchment Management Declaration, which was basically trying to encourage many organisations to sign up to this declaration of better working within catchments, better collaboration, and this was supported by Prince Charles. But it's basically, from a water company perspective, it's about investing in our catchments, not just locking ourselves away in our water treatment works and dealing with the challenges there. We're actually going out into the catchment, see if we can address some of these problems at source, and that's going to be better for us and better for the environment. We've got to work in partnership though in catchment management. This is not something we can do in isolation. Obviously there are many other beneficiaries of good catchment management. It can have benefits for natural flood risk management and biodiversity. So we have to work with others as well. And it's good just to highlight that sometimes when we speak with farmers, that it sometimes feels like we're pointing the finger at them and why are we only targeting them. But really it's reflective that it is the biggest land use in many of our drinking water catchments is agriculture. And it is some of those inputs that are having an impact on us. So that's really why much of our work is focused with agriculture. So what's the issue? Obviously, like I said, we're a very densely populated part of the world. There's lots of pressures on the land, and these pressures put pressures on our water sources as well. So there are many things that can impact the freshwater environment, and as this is where we get our water from, there are things that we have to manage. Some of these pollutants that can end up in water, we have to spend money and time in removing them. And then there are risks of compliance failures if there are pollutants in the water. These are very rare, but there is a risk there. And this can affect consumer confidence. And if a water source becomes heavily polluted, then we lose that source, and that puts further pressure on our remaining sources of water. So what specifically are we talking about? Pesticides in water. This is quite a high-profile issue. Things like metaldehyde and other actives can and do end up in water. Nitrate in water. This is mainly a problem in groundwaters, but also some rivers are seeing increasing concentrations of nitrate. And turbidity, which is probably very relevant to the audience today, is sort of soil loss to water. And this is something that we have to remove as well. But there are other issues as well. This isn't, like I said, this isn't just about agriculture. There are many other risks, and even us as an industry, as ourselves in the water industry, we do obviously cause pollution incidents, and we have to manage those as well. So I'm just going to focus on the top 3 of that list now, starting with pesticides. And like I say, many pesticides are found in water. We're talking about very trace concentrations here, but we do see a whole range of pesticides in water. And we have a drinking water standard of 0.1 micrograms per litre. That's 0.1 parts per billion that pesticides have to remain below when we're supplying water. This is not a health-based standard. It's set by the EU, and it is the same limit for every individual pesticide. Some of these pesticides are not treatable. Metaldehyde being an example, the active ingredient in slug pellets. But it's not just about metaldehyde. Others are energy intensive and costly to remove, like propyzamide, for example. But like I say, it's a broad spectrum, and the other pesticides like glyphosate is very easy to remove for us as a company. And we do get occasional failures at tap. We occasionally are supplying water that will have slightly more than the drinking water standard of a particular pesticide. And this is an issue. Like I say, not a health-based issue, but a compliance issue for us. And this just highlights this just gives you an example of the problem. This is a graph that highlights propyzamide concentrations in the River Thames over the past 8 years. As you can see, each year we see elevated levels of propyzamide above the drinking water standard, which is the dotted red line. So it's our job to remove that propyzamide to below the drinking water standard. And obviously there's there are cost and technical implications of that. The main method we use to remove pesticides is something called, we use granular activated carbon and ozone. And GAC is basically finely ground carbon, which we sort of then put into a filter, and we filter water through it, and this enables the pesticides to adsorb to the carbon, a bit like you'd see in a Brita water filter at home, for example. Okay. So the next thing I'd like to highlight is nitrate in water. And this is an increasing problem in groundwater. Again, we have a drinking water standard for nitrate. Nitrate naturally occurs in the environment, but obviously we are also seeing increasing concentrations through sort of anthropogenic reasons. Unlike pesticides, the nitrate standard is a health-based standard. So this is set by the World Health Organization, and it's on us to obviously ensure that these concentrations stay below 50 milligrams per litre. Nitrate leaching, it does come from multiple sources, but agriculture has been identified as a big cause, certainly in the more rural catchments. And it is a historic problem. Nitrate leaching does take many years to filter through into the groundwater, but it is also a current problem as well, which I'll highlight in the next slide. And nitrate is difficult and costly to remove. We use something called ionic exchange. To put in one of these plants costs about £5 million, and it's technically difficult to manage that process. If we don't put in this treatment plant, we have to blend the water. So if we have a high nitrate source, we have to blend that water with a low nitrate source to enable us to keep the water below the drinking water standard. And blending in itself is a costly process. It's not something, it requires energy to pump that water and infrastructure to enable us to do that. Okay. And this is another graph just highlighting water quality data. So this is nitrate concentrations over time at one of our groundwater sources. The solid line is nitrate concentrations, and the dashed line is groundwater levels. And the red dashed line at the top is the drinking water standard for nitrate. This particular source doesn't have treatment and has limited blending capabilities. But as you can see, there's a general increasing trend over that time, but also we're seeing these seasonal peaks. And we see these peaks in sort of winter, springtime, and this is basically when the groundwater levels are rising, and they come into contact with what we call the unsaturated zone, and this is where a lot of more recent nitrates have leached into. So that liberates this nitrate and raises the nitrate concentration. And as you can see, in recent years we're getting critically close to that drinking water standard for nitrate, so it's a key issue for us. Okay, thank you. Final thing, turbidity. This is basically sediment in water, the cloudiness of the water, and this can often be caused by soil loss to water. Again, there are multiple sources that cause turbidity. It's not just agriculture, but turbidity can be a big issue in more agricultural catchments. And the first step in most water treatment is to remove this turbidity, and that's called clarification. That's where you dose the water with a particular chemical, and this basically makes the sediment clump together and enables you to separate it from the water. As we've estimated that this costs us between 1 or 2 million per year to manage at our River Thames abstractions. And we end up with a product called cake. And this is basically that condensed sediment that we've removed. And we either have to basically dispose of it or ask farmers to take it off us to spread it back to land. It's not very nutritious, it's more of a soil conditioner, but it is, there's energy and time involved in that process. Final thing I want to just talk about, which I think will be of interest to you in the room, is our water resource situation. Like I mentioned earlier, the southeast is an area in serious water stress. We've got an increasing population. We've estimated that will increase by 1.4 million people by 2080. And we've got the uncertainties around climate change. And this graph here just shows the increasing deficit we will have in the coming years with that increasing demand. The blue bars at the bottom are basically the amount of water we have available to use, and the blue line is the increasing demand that we will face. So if we do nothing about it, we are going to have some serious deficits in the years to come. But we have recently published our draft water resources management plan, and this is where we set out ways in which we're going to meet that demand, and that's through encouraging water saving amongst households. Current water usage is about 150 litres per day per person in the UK, so we're trying to encourage our customers to use less. But that will only get us so far, and we need to invest in infrastructure, reduce our own leakage as a water company, and that will help us get there. But this will cost us £1 billion across the next 60 years to get there. And what I'm really interested in, and is something that we've not really factored into this model yet, is understanding how land management change could maybe give us a little bit of increased resilience. Could, for example, if the no-till movement increases and if we have more of this type of farming in our catchments, could that mean more infiltration of the water into the ground that could end up in the aquifers? Could that actually mean we would have a little bit more water to use, give us that little bit of resilience in a tough year? Okay, so those are some of our challenges. I hope that hasn't come across as too negative. But there are some potential solutions, and we're currently working on various projects. We have some catchment management projects trying to address particular pesticide pollution. We're supporting stewardship campaigns. We've got some targeted catchment schemes focusing on metaldehyde and oilseed rape herbicides, things like propyzamide, carbetamide. And we're investing in research, trying to find better ways of limiting that loss of pesticides to water. And we're also beginning to look at catchment management for nitrates, investing in research again, looking at the role of cover crops, what they play at reducing nitrogen losses to groundwater. But can we go further? Can we start maybe looking at catchment management for soil health? The above are trying to address individual issues, but maybe we need to be supporting better soil health within our catchments, because we will get multiple benefits from that. But this is only going to be achieved through partnership working. And it chimes very much with this idea of natural capital and payment for ecosystem services, which is obviously being talked about a lot currently, and certainly by our government. But we've got Brexit as well as a potential risk, but also opportunities for this type of movement. Okay, thank you. So this is a little bit of blue sky thinking to finish with. I came here last year, I heard loads of fascinating talks and been sort of learning more about no-till and soil health over the past year. And I just want to sort of highlight some of the areas where I think maybe, more no-till could benefit us in the water industry and the wider water environment. So, it could mean reduced pesticide use on farms, reduced fertilizer use. And actually, if the soil has a better integrity, that means that you get reduced losses of those inputs anyway. And we could get reduced sediment loss as well. Increased water infiltration. Maybe less crop irrigation as well, certainly at times like this. It could contribute towards natural flood risk management. Increased biodiversity. And also, contribute towards tackling climate change. And I know that's very optimistic, and I'm a sort of realist as well, and I know there are lots of real-world challenges around a lot of those issues, but a lot of what I heard last year, got us excited about a lot of these issues. So yeah, that's all I'm going to say really. And we're here over the next 2 days. We're not just here to hand out free water and promote our company. That's not really the purpose. We're just here to talk to as many of you as possible, have some interesting conversations and learn. So yeah, please do come and speak to us, and I hope you enjoy the event. So thank you.
Time for a few questions if you've got any. There's one.
Okay.
Sorry. No, go back to Mike.
Okay, thanks.
Hello, Graham Willis from CPRE, an environmental charity. I've heard a guy from Wessex Water talking about the cost of nitrate removal, in a kind of closed session. I just wonder whether those figures are out there, because I think that kind of figure might play well with the government and policymakers in this, making them think harder about how you cut costs for water industry and consumers. Is that figure published? Is it something you have for Affinity?
Yeah, I mean, I don't have a specific figure for Affinity. I certainly was asking around before giving this presentation. It's really actually quite hard to bring together all these different costs, and I think that's something we should definitely work towards. Put some of these figures out there. I know some people have done some work. I think the Green Alliance produced some figures last year on the total cost of nitrate to the water industry. But no, you're right. I think we need to get better at maybe quantifying some of these figures, definitely.
Okay, Gottlieb Pasch from the European Conservation Agriculture Federation. Just two questions. First, do your stewardship campaigns include conservation agriculture or no-till? Well, you mentioned it right at the end that no-till or conservation agriculture could actually contribute a lot to your objectives. And the other one is whether Affinity has had any issue so far with glyphosate and water quality.
To address your first question, I mean, at the moment, we are, like I said in the presentation, we're targeting all sort of individual issues, I suppose. We're targeting metaldehyde pollution, and then we're looking at other pesticides that are causing us a problem, and nitrate. But yeah, like I say, I think we need to look a bit more holistically and see how we can encourage management practices like no-till in certain targeted areas where we could see a benefit. I think that is definitely an area that we need to move into. We still need to maybe understand some of the exact water quality implications of those particular types of farming, but it's definitely something we're looking into. We're already funding a bit of research with Rothamsted to look into the water quality impact of no-till compared to conventional farming. So it's definitely something we want to explore. Glyphosate, yeah, we do detect glyphosate in water. We detect it throughout the year. It's a commonly used pesticide, herbicide. Currently, for us as a water company, it's quite easy to remove. It doesn't cause us the challenges like metaldehyde and propyzamide causes us. But there is still obviously a cost to removing that pesticide from the environment, from the water. Sorry. But it's associated with the cost of removing all other pesticides. So it's not something we're really focusing on.
Hi there, I'm Adam Keys, a grower from Thames Valley area. We grow organically and use a lot of green manures, and I was wondering if you know any information around the impacts of green manure incorporation. Obviously it's a high level of organic matter and nitrogen being released. I was wondering if you've got any ideas around that.
Yeah, I mean, I think we need to do some more work on identifying sort of impacts of specific types of fertiliser or soil conditioners on, say, nitrate leaching. I mean, I would think that an organic source of fertiliser should be less risky in many respects than maybe an inorganic form. I know there may be some exceptions to that, but it depends on the timings, obviously, timings of applications and all the other considerations. But yeah, we don't have a good grasp of specific materials as yet, no. But I think the information is out there maybe by others, yeah.